Hello, this is a short video presentation for my poster, Aspects of Quantum Gravity in the Standard Model from Nonnoetherian Spacetime. Nonnoetherian spacetime is a Lorentzian manifold that is modified by defining the world line of a fundamental classical particle to be a causal curve with no distinct interior points. Such a one-dimensional event is called a pointable curve and has no tangent space. This feature gives rise to electric and color charge. We refer to the Lorentzian manifold as emergent spacetime, denoted m tilde, in the new nonnoetherian geometry as spacetime, denoted m. In our model, we consider pointable curves alpha that are closed segments of helices centered about causal geodesics beta. Let omega be the angular frequency of alpha in the inertial frame of beta. We define the form momentum p of alpha by the Planck-de Broglie relation in the direction of beta dot, as shown here. Suppose beta is time-like. In the inertial frame of beta, alpha is a circular trajectory of radius r, angular frequency omega, and tangential velocity v. We define the mass m of alpha to be its curvature, 1 over r. Consequently, the energy E naught of alpha in the inertial frame of beta is given by E naught equals mbc. A pointable curve is on shell if and only if v is the speed of light. We thus obtain a description of off-shell particles that does not violate relativity. P squared equals E naught squared always holds. We represent pointable curves by the chiral spinors psi L and psi R. From E naught equals mbc, we propose a Lagrangian density for pointable curves, where the derivative of the tangential speed v is with respect to arc length s and not time. By the variability of v, the classical equations of motion of L coincide with certain non-vacuum quantum motion determined by the path integral of the free Dirac Lagrangian. Now, an apex is a point x in m tilde where the chirality of a pointable curve is flipped, given by the only two interaction terms of the Lagrangian. As shown in the poster, an apex is the creation or annihilation of two pointable curves of opposite charge. In our paper, the standard model particles are modeled by bound states of pointable curves. In this example, we have an electron emitting two photons with the apexes circled, and on the right we have the corresponding Feynman diagram. The absence of the chiral mass terms in the Dirac Lagrangian implies that the pointable particles represented by psi L and psi R do not source gravitation as they propagate. The Einstein equation on emergent space-time m tilde is therefore given as shown, where 1a is the indicator function supported on the apexes in m tilde. This modification resolves Bohr's famous Gedanken experiment. Furthermore, the Einstein equation is recovered in the classical limit, where energy and momentum are measured at each point of m tilde. Thank you very much for listening.